Hello, this is Mr. Wynn, and this video is quadratic systems. So remember that a system is two or more equations. In a quadratic system, at least one of the equations will be quadratic. In our class, we only have two cases, one quadratic, one linear, or two quadratics. So there's three examples of each and how they could intersect. Notice on the first one, there's two intersections, one right here, one right here. The second one has one intersection, the third one has no intersections. Down here, we have two intersections right there, one intersection right here, and the other one has no intersections. So you can graph them, count how many solutions or intersections there are, but we know it's going to be 0, 1, or 2. Also, we want the exact coordinates, so graph isn't the greatest, it's just for sketching. So algebraically, we can find the exact spots, and the steps are simple. First, you're going to set the two equations equal to each other. Sometimes you get them both into y equals. Then you're going to solve the quadratic equation. You usually get it equal to 0, and either do factoring or quad formula. And the last thing you do is, since the solution is a point on the graph, since you know the x's, you have to plug it in to find the y's. Again, the xy coordinate is the solution. So here's an example. Find where that quadratic y equals x squared minus 5x minus 30 intersects the linear line y equals negative 7x plus 5. Since they're both meaning y equals, I'll set them equal to each other. The first equation equals the second equation. Because it's a quadratic, I need to get 0 to one side. I'm going to add 7x both sides first. So I get x squared plus 2x minus 30 equals 5. I'm still not done. I move the 5 over by subtracting it. So x squared plus 2x minus 35 equals 0. Maybe you have two options. You can either factor, which is the fastest way, or you can do quadratic formula. I'll do both. I'll factor first, though. I'm going to check for GCF. There's none. I'm going to do guess and check. There's only one guess possible for the first x squared, so x times x. For 35, I can do 7 and 5. That could make 2x. 7 has to be positive, the 5 has to be negative. And that works. Then you set each factor equal to 0. So x plus 7 equals 0, and x minus 5 equals 0. They're one step. The first one just subtract 7, so I'm done. Second one I add 5, and then I'm done. The answer is not the x's. That's half of the point. We've got to find the y part. To find the y, just plug in the x value into either equation. You want to pick the easier one. The first one's quadratic, so I'm going to stay away from that. The second one is linear, so I'll use that. So let's see, I'll plug in negative 7 first. So negative 7 times negative 7 plus 5. That's positive 49 plus 5. That's 54. My first answer will be, I'll go down here, negative 7 comma positive 54. Then for the second one, I'm going to plug in 5. So y equals negative 7 times 5 plus 5. Negative 35 plus 5, that's negative 30. That's my second answer. And positive 5 comma negative 30. So this one has two solutions. If I graph them, and they would cross twice at those 2 points. Now, so I do quadratic formula. So back to this step right here. We do quadratic formula. We label A, B, and C. A is 1, B is 2, C is negative 35. The formula goes negative B, so opposite B, plus or minus square root B in parentheses, squared minus 4 times A times C, all over 2 times A. You work on the inside. So that's going to be negative 2 plus or minus 2 squared is 4. Negative 4 times 1 is negative 4 times negative 35 is positive 140. All over 2. Still working on the inside. So negative 2 plus or minus square root of 144 over 2. Remember that number, the 144 is called discriminant. That tells you how many answers there are. If it's positive, there's two solutions. If it's 0, there's one solution. If it's negative, it's no real solutions because they're imaginary. We're not going to square root the 144. Square root of 144 is 12. Then I'm going to do the two cases. The adding problem, negative 2 plus 12 over 2. And the subtracting problem, negative 12 minus 12 over 2. So that is positive 10 over 2, which equals 5, our first answer. That's negative 14 over 2, which turns into negative 7, which is our second answer. But then you have to plug it in. So you have to get the negative 7 and 5 by solving by either factoring or quad formula. Once you have the x's, you have to plug in for the y's. So here's another one. Find where f of x equals negative x squared plus 2x plus 3. That's a quadratic. Intersects f of x equals 4. That's a linear. That's actually a constant. Since already y equals, we're going to set them equal to each other. Negative x squared plus 2x plus 3 equals 4. This is quadratic. I need to get everything to one side, equals 0. I move everything to the right side because I want the x squared to be positive. So I'm going to add this over. Those do not combine. So that's still 2x plus 3 equals, I'll put the x squared first, plus 4. Just got to move the 2x over, so I'll subtract that. That doesn't combine with anything either. So 3 equals x squared minus 2x plus 4. I move one more thing over. I'll subtract this 3. So this is 0 equals x squared minus 2x plus 1. From here I have two options. I can factor a quad formula. I'll factor first because that's fastest. 3 terms. There's no GCF. I can do guess and check. There's only one guess for the first one. X and x. There's only one guess for 1. 1 and 1. Can 1 and 1 make 2? Yes. I need a negative 1 and another negative 1. That makes a negative 2. Multiplies a positive 1. So each factor equals 0. X minus 1 equals 0. X minus 1 equals 0. It's the same problem twice, and that's okay. I add 1, so I'm done there. I add 1, I get 1 there. It's the same answer twice. Right, remember once you have the x, you have to plug in for the y. I'll plug either equation. It's your choice. The second one's easier. If I plug in 1 for x here, nothing changes. It just stays 4. So this is 1 comma 4. But if I use the first one, say you didn't like that, you use the first one, it'd be negative parentheses 1 squared plus 2 times 1 plus 3. That's negative. That's 1 comes out of that, plus 2 plus 3. Negative 1 times 1 is negative 1 plus 2 plus 3. That's positive 1 plus 3. That's 4. So you get the same answer. Alright, so that's the fast way of solving it, but we could do quad formula again. So from this step right here, which way did I draw the arrow earlier? Okay. So I'm going to label A, B, and C. So A is 1, B is negative 2, C is positive 1. You fill in the formula. Negative b plus or minus square root b in parentheses squared minus 4 times a times c all over 2 times a. Work on inside. So 2 plus or minus square root. Negative 2 times negative 2 is positive 4. Negative 4 times 1 is negative 4. Times another positive 1 is negative 4. All over 2. Work on the inside. 2 plus or minus square root. 4 minus 4 is 0. And the inside 0, the discriminant is 0. That means there's one solution. It's the same answer twice. I'll square it 0, which is just 0. So 2. Now do the two cases. Use black. So this will be 2 plus 0 over 2, and then 2 minus 0 over 2. This is 2 over 2, which is 1. This is 2 over 2, which is also 1. So that's how you get x is 1. Again, you need either factor or quad formula to solve for the x's, but you must plug it into one of the two original equations for the y value. Alright, next one. If I were those two intersect, it's really y equals y equals. So they equal each other. This is two quadratics. Alright, I need it equals 0, so I'm going to move the x squared over by adding it. I move the 6 over by subtracting it. Just negative 10 equals 0. There's my quadratic equals 0. I can just solve by factoring or quad formula. Let's try factoring. 3 is prime, so there's only one guess for that. Let's do 3x and x. And for 10, we have a couple options. 5, 2, that does work. That gives us 6 and 5. 6 and minus 5 is 1. So I need a positive 6, negative 5. And that multiplies correctly. So both equal 0. So the first one I add 5 first, then I divide by 3. So the second one I subtract 2. Got my two x's. If I did quadratic formula, I get the exact same answer, so I'm not going to do it this time. The discriminant would be positive because there's two answers. I'll plug in the x's to find the y's. The second equation looks shorter, so I'll use that. So I'll plug in negative 2 first, so negative parentheses negative 2 squared plus 6. We're going to the inside first, that's positive 4. After we do the exponent. Negative 1 is positive 4 is negative 4 plus 6. That is positive 2. So our first answer is negative 2 comma positive 2. The second one's going to be harder. I'll use blue. We're playing a fraction. Negative parentheses 5 over 3 squared. This is a single term inside, so I can distribute the square power. So 5 squared is 25. 3 squared is 9. That's just negative 25 over 9. I need a common denominator, so I'll fix right here. Times this by 9 over 9. That's 54 over 9. They can now combine. Negative 25 plus 54 is positive 29 over 9. that does not reduce. So that's our second answer. So, and 5/3, comma 29 over 9. All right, one last example. Find where this quadratic intersects that quadratic. This is y equals, so I'll set them equal to each other. Don't need to move anything, but sometimes you have to move stuff. Got equal to 0. I'm going to x squared over by adding it. I move the x over by adding it. I move the -7 over by adding it. Here's my quadratic. I can either factor a quad formula. I'm going to try factoring. 2's prime, so under 2x and x. Over here, I try 2 and 2. That fails. I try 1 and 4. That fails. I try 4 and 1. That fails. This is unfactorable. If it's unfactorable, you have to do quadratic form. There's no other option. So I'm going to label A, B, and C. A is 2, B is 3, C is 4, negative B plus or minus square roots B in parentheses squared minus 4 times A times C. All over 2 times A. Work on the inside. So negative 3 plus or minus square roots. That's 3 squared is 9. Negative 4 times 2 is negative 8. Negative 8 times 4 is negative 32. All over 4. Still working the inside. 9 minus 32 is negative 23 over 4. The discriminant's negative. If the discriminant is negative, that means there's no real solutions. No real solutions. The answers are imaginary. We don't care what they're mentioning here. You do is circle with a slash through it. And that's it. Hope you enjoyed the video. Make sure you ask questions in class. See you soon. Thanks for watching. Bye.